Okay, so today, as I mentioned in the message, I will be focusing on the basic libraries which you would need for your data science pipeline. More specifically, I will be focusing on Pandas and NumPy. So before I go on to explain what each of these things are, I don't want to sit and just give you guys theory because it's boring, to be honest. So I will take one example, and it's a challenge. It's a challenge on Kaggle. If you guys are attending the session I took the last time, I mentioned about Kaggle and how you can get data from here. So for those of you who don't know, or if it's the first time you're looking at this, this is your best friend when it comes to data science. This website will not only give you data sets, so almost anyone who wants to start with data science initially would have to go through Kaggle. So any data set you pick up from here would be something you can work on and learn from. And the best part, if you haven't seen Kaggle before, is that many of the challenges, so suppose I take the one which we will handle today. So this one is on, it's a data set of the Titanic. So everyone knows about the Titanic. So I thought I'll take something like this so you can maybe understand what we are trying to achieve through a sort of bigger example than just general syntax. Okay, so this competition is sort of one of the most fundamental and beginner competitions. So after I'm done with today's session, I'll be sharing the links of all of this. So I would request everyone here today to play around with this data set because it's a really good way to start. And how you would generally go about getting stuff from Kaggle is you first make an account. Once you have an account, just search for a competition. Okay, and then just go to data. So that's your most important part. This bit here, that is the most important thing. And what you should do is first read about the data. So I'll skip over this and I'll explain it later. But the point is, have a look at this description. This is common for everything on Kaggle. So once you get this done, then have a look at this. So more often than not, you can just click download all. If you are trying to run this on something online, which I will again tell you about it in a little while, you can use the API. So for those of you who don't know, an API is basically just a command. So like if I'm on my terminal, I would type Python something. On this case, I could just copy this part and paste it. And then if I run this, then I will get my competition downloaded. I would get everything here along with all this information downloaded in one go. Okay, so that's how you get data. And now today's aim is to explore the data. And the whole point of being in data science is to take any data you've been given, say just this Kaggle competition data, and then extract as much as information as you can from it. That's your job. That's what you will be doing in most of the cases, and I will show you guys the way I go about it in general. Most competitions from Kaggle, you can follow this template. To be honest, once you get a hang of this, you will be able to at least approach majority of the challenges on Kaggle. And so personally, I would consider knowing about pandas and NumPy as one of the most important things in data science, if you're doing it on Python, obviously. Um, so pay attention, and of course, at many points, it might feel like there's just way too much syntax, and that's cool. I guess you don't need to memorize any of this. I will tell you how to know what to use when, and I will show you examples. I will try to code while I'm giving this presentation. Okay, anyway, before I actually go on with today's content, as a quick check, I'm audible, right? And you can see my screen because it's going to be fully uh, on the screen. Okay, great. So before we go to the data, let's first identify or understand what we have, because that's important. And without knowing what we have, we can't do anything with that data. So if you look at it, Kaggle will show you a small bit of the data before you download it. So this is what we have. We have a few columns. Some of them are numerical values, some of them are text values, and some of them are just strings. So cabin number is a string. Ticket is also a string, but with numerical values. Our job is to understand this variable. So the most important thing is this, survived. Survived is quite obviously the people who managed to survive the Titanic. And this data set is a real life data set. So it's not generated. It's been collected from actual data from the Titanic. So our job is to identify probably many factors which relate to this variable of survived. So how you would do that initially is first you load the libraries as usual. Um, so as a brief background, Pandas is used for tables. So anything which is a table, you would require Pandas to load it. And it just makes many things way easier than it would have been if you were just loading it from a text file. Um, for example, if you look at just the text file, which I will show you at some point, you will see that the way if you want to just write it in pure Python, it would be irritating. It would honestly be irritating. As an example, okay, you can ignore what I'm writing right now. It's just me going to that file. So it's fine. By the way, this is the Linux terminal. You might not really need Linux right now. If you do have it, that's great because it'll be really helpful. And at one point, using and doing data analytics or even machine learning is a little irritating on Windows. So, I mean, if possible, I would suggest at least have an Ubuntu system or any other Linux system at a later point. Initially, it's fine. Initially, anything's fine. Okay, so if you see this file right now, it looks very neatly formatted. So this pandas does for you, and it's a simple command, read CSV. So if you see, CSV is just the name of the file. It's an extension. And why it's called CSV is, so right now all I'm doing is I'm printing the file. So if you see, this is how the file actually looks like, this bit. And if you see, all of these are separated by commas. So this is how the file is saved. And it's called a comma separated value file, so or CSV. Um, General knowledge per se, it's important to know because sometimes you might encounter situations where you can't use pandas. Uh, I mean, later at some point. There you can use this format. So you can read it as a normal text file and then separate it by commas, just as an example. Okay, so if you see just the difference between how we read it just using it as a text file or you reading it from pandas, see how different it is and how easily formatted this is. I mean, if you want to read the whole data set, or if I want to read, say, the first 100 lines, it's kind of irritating and you can't really do anything with this directly if it's a text file. So this is why we use pandas. Um, I will show you more examples now. Okay, so once you have the file, generally what you do is you need to explore it. You need to see what your data is. Now this is a very small data set. So if you do head, all it'll do is it'll give you the first n rows. So if I do head 10, it'll give me the first 10 rows. Similarly, if I do tail, it'll give me the last few rows. Why this is important is once you do this, you can see what's there in your data. So you can see the types of data structures you have, just the variables. So ticket, now you know that it's not only numbers, uh, and it also has text. Now this is important. Similarly, you see a lot of NaN. Okay, so this is another important thing, NaN. NaNs are missing values. So for example, when someone was collecting this data, they found some cabin numbers. So C85, E46 or something, but some of them they couldn't find. So there it's a missing data. And why this matters is because when you try to perform some calculation on it, so if I, okay, so this is an important syntax. So all I'm doing is that df is the name of my data table or data frame or whatever you want to call it. All I'm doing right now is I'm trying to extract one column out of it. So suppose I want this column, I want cable. So all I do is I do this. So df bracket cable, and this can work with anything. So I can do survive or whatever. Okay, but just as a case, let's take the instance of cable. Okay, now you have all the values in this column. It doesn't look like it, but if you see here, the length is 891. Okay, now how would you verify that this is the whole column or the whole data? So a small syntax is shape. Shape basically gives you the number of rows and number of columns. So here you have 12 columns and 891 rows. Now, the whole point is you need to explore your data. You need to find out stuff which you wouldn't just by looking at it. So if it seems like a lot of syntax, just try and see what we're trying to do. Again, it might seem a little overwhelming because there's a lot of these things, a lot of words, a lot of syntax, but it's fine. You don't need to memorize any of this. To the point that if you get just this document which I'm using, you can do analysis on a large number of data sets without even changing anything. So it's not the end of it all. Of course, there's a lot of stuff and it's not really possible for me to cover everything. But once I'm done with today's webinar, and if you have listened to it properly, you can pick up anything on Kaggle and at least understand what they're trying to do. Even if you can't do it initially, at least you will be able to follow along. So just see the pipeline. I will skip over some things because I will come back to them later. And I'm not following any particular order or tutorial, just showing you the way I would deal with being given this data set. Okay, so the first thing you should identify is what do you want? What do you want from this data? And right now, according to me, what I want is that I want this variable survived and I want to compare it with the others. So I want to see how each of these things relate to survive and maybe try and identify some trends or some features which me just looking at this much of the data doesn't give me. I won't go into anything advanced today. So just have a look at the pipeline. Okay, there are people drawing on the screen. Okay. So the first thing you would do is something called describe, and as the name suggests, which is important because I believe many of you here are just starting off Python. Uh, for those of you who have just started Python, you might feel like there's just too many things to memorize. But the one good thing about Python compared to say C or something is that everything does what it says. So if you want something like describe, it will describe the data set. There is nothing else to it. So if you know what you want to do, it's way easier for you to learn Python or data science to do that for that matter. So as an example, to continue on this thread, if you want to say see which of these values here are greater than some value. So for example, I have P class. So P class according to here is just the class, excuse me, of the passenger. So whatever, first class, second class, third class. Yeah. P class is just the ticket class. And what I want to do is I want to see the distribution of P class. That means how many people were there in every class. And the easiest way to do this is a bar graph. I'm pretty sure everyone's encountered a bar graph at some point in school or college or whatever. And if you see, it's really easy to plot it. If you had to do this on your own, if you had to write a separate script to do just the counting, it would be irritating because you would have to generally write a for loop and maybe sum over all of these values and then put them into separate arrays and then plot it. but you don't need to do any of that if you're using Pandas. Okay. Another library called Seaborn is just for plotting. So don't get confused. All of these are different libraries, but they are linked. So if you want to use Seaborn, it's just for plotting stuff. So whatever you take from this data set, you can plot it. So as I was saying, if I want to plot the P class, so all I do is something called a count plot. Again, more syntax, but if you just see what are we trying to do? We are trying to plot the counts of every variable or everything in P class. Before I show you this properly, just have a look at P class. Uh, if you see, I'm still using the same data set. All I'm doing is I'm indexing into the data. So if I want to see P class, I do df of P class. And now I see that there's all these numbers and there's 891 of them. And all I'm doing is that I'm plotting it here. So now I can see that a majority of these people were in the third category of the ticket. Okay, but what do we get out of this? If you think about it, nothing. I mean, okay, it's just a simple sum. And why would you want pandas, or what's there in analysis on this? So analysis generally on one variable is cool, on one column is cool. But if you want even more information, you have to compare two columns. So if I want to take um, the relation between people who have survived and their P class, say, how do we do that? How do you think you would do that? Yeah, I'll pause for a few seconds. Just try and think of how you could extend this part to account for two columns. Say one more column df of survive. So yeah, think of maybe how you can add this and this. If you think about it, it's really simple. All you have to do is take this value and put it here. And if you see, this is not going to work. Why this won't work is because right now you're saying that this whole thing is a column, and it's not. They're separate columns. So all I did is that I selected these two and I put them in another bracket, which means that I'm saying they're different columns. These things, sorry. Okay, again, why it didn't work. Yeah. Why it didn't work is because of this syntax, count plot. I would have done it just like that, but I wanted to show you guys what happens and maybe how you would identify the errors, because it's an important thing later when you go into it. So as I was saying, you would think that this works, but every library has its own syntax, right? And the only way you could probably go about this is look at the documentation. So if you're using a Jupyter notebook, you can easily do a shortcut called Shift Tab. So click anywhere in your function. So suppose I want to know what count plot is, or maybe if I'm trying to do a count plot and I've forgotten the syntax or I've forgotten what it is, I would generally Google it, but you don't need to. Just click inside the bracket, anywhere inside the bracket, and then hit Shift and Tab, and you'll get this. You will get everything about it. Obviously, you don't need to use all the parameters. You will get examples. If you scroll a bit, you see there are examples. So these guys have also worked on the Titanic dataset. So the examples of this is also from here. This is extremely useful because, I mean, if you're in a flow, it's kind of irritating to keep Googling all the time. So make use of this thing a lot because it comes in handy. Okay, now to see the other one, which I was trying to do, right now I want to see, so I want to see the relation between, say, survived and gender, say. Now, this is syntax I was talking about. If I remove these brackets, you will get an error. Because right now, if you see here, And this is how you understand what's gone wrong. If you see this, it says this is an error. This whole thing is an error, which means that there's nothing like survived comma gender or survived comma sex in this. It's separate columns. So all you have to do very simply is just put them in another bracket. And right now Pandas sees this as two separate columns. Okay. Obviously you can extend this to as many columns as you want. You can get anything, but that's not my point. My point is right now I have this. And now out of these two columns, I wanted to see how many of these guys have survived. So syntax is almost the same, maybe a little different. So I'm just going to copy this so it's easier. Okay, let's just take this. So all I have to do is, if you see this syntax, I'm taking any of these things. So I'm taking, say, survive, and all I'm doing is seeing this. So if you think about it, it's very simple. This is the initial thing. I have tried to see in this whole column how many of these are equal to 1. As soon as I type this, you see Pandas has made it into false, true, false, true, false, true. So all of the ones which are true are obviously equal to 1. And now all I'm doing is that I'm taking this and I'm plugging it into my index. So I'm using this as the index. Once I have this, then I have a whole data frame of places where they have survived. So if you see, the previous one had 891 rows. Now I just have 342. So quite obviously there's 342 of them who have survived. But again, for a larger data set, you could just maybe index into this again. So this and a separate index again, and I will get these values. Similarly to the previous one, you can also add stuff here. So you can do maybe age, comma, survive, or if you want to just see the age of people who have survived, you can do that as well. Okay, I guess Zoom has a limit. So if this meeting gets over, I will put up another link. Maybe you can join that. Zoom has a 40-minute limit. So yeah, before it goes on, I would like to emphasize a lot on this syntax because it's extremely useful. As more examples, I will show you something like this. So if I want to see any cable number, so this is another small bit of thing. So if I take the cable numbers, I have this. Now, how do I identify the unique values? As the name suggests, again, all I have to do is dot unique, and these are there. So these are all the unique columns. Um, if I take something like fair, say, again, just to remind you, what are we trying to do? We are trying to identify and understand the data. And to do that, we have to first see the values in it. So for all the numerical columns, you can easily find a min, max, and all this. And if you see, the syntax is still the same. Over here, it's dot unique. Over here, it's max, min again. So as long as you know what you want to do, it's really easy to do it with pandas. Um, Okay, most of these things are just examples of the same thing. So if I want to say find, instead of age, let's take something like, say, Mbappe. And then I can just easily plug it in and then I'll get this. And again, I can chain this as well. I can do a unique. Okay, so this is not going to, oh, sorry. Again, if you see, this is just a chain. It's an addition to everything before. And you can do all of these separately, or you can just put them in one line. I'm used to it, so I put it in one line. If you're not comfortable with it, you can easily just name it to a variable and then do it for the variable. That works as well. So the point is, out of this, it's not a very important factor here, but we can do this as well. We can chain multiple things. So if you learn this one block, you can chain it to this. If you learn this block, you can add it to this as well. And to finish off the whole pandas discussion, let's talk about plots. Let's talk about some very simple plots. And maybe let's just look at bar graphs for now, or count plots per se. Um, count plots are, again, just by looking at it, you can see it's extremely important because now you can literally pick up anything. You can pick up, say, passenger ID isn't a very important feature, but let's pick up cabin. And you won't be able to see these labels. But anyway, if you want to see just the labels, I think I've printed them a while back. The whole point is that you can plot each of these things. You can see the unique values of them, and then you can plot them to get a distribution. Uh, from this, there's a way to tilt these values so you can see them, but again, too much syntax. So I'll send you guys a link to it. You can have a look instead of me explaining every bit of syntax. Uh, if you can see, it's kind of obvious to see the ones which are above the rest of them. And this is another way of understanding the data. Um, the last thing which I would like to talk about with respect to pandas is that everything, every bit of data you pick up is an array, is a NumPy array, or a series, Pandas calls it, but it's still an array. And that brings us to NumPy. I will send you guys another link to the next part of this session because Zoom is going to stop this very soon. But again, before it closes, let's just talk about these two things. This is a histogram. And if you just skip over the syntax and if you just look at it from a layman's perspective, what am I trying to do? Again, all I'm trying to see is a distribution of people. So these are different ways of doing the same thing. I can use the Pandas syntax to plot a histogram, or I can use Seaborn. So why I wanted to show you this is that you realize that there's not just one way of doing things. There's many, many ways of doing the same thing. So you don't need to worry about the syntax as long as you know what you want to do. So if I know I want a histogram, I can either do this or I can do this. This is, it looks much nicer, I guess, than this, but it works. It does the same thing. And from this, you can easily see that majority of the people were in this range, which would have been harder for you to guess if you just had numbers. So if you look at any of the Kaggle kernels, just as an example, if you click notebooks, you will be given examples of stuff people have done. And I will show you, I will share the links of some of the good ones for Titanic, so you can have a look. You'll see a lot of these plots. You'll see histograms, you'll see other plots. So if I type, you can see there's a lot of types of plots which are there. There's violin plots, there's a lot of stuff. Um, again, you might have to format your data a bit for it, but the best part is you can just do, as I was saying, shift tab, and it'll tell you what you have to do to use this. Examples, things of everything, parameters. So make use of this. It's extremely useful and it'll save you a lot of trips to Google. Because I mean, if you are in a flow, it's irritating to keep switching tabs and searching for stuff. So that was a basic introduction to pandas. Before I stop this bit, anyone who isn't that familiar with Python, it's cool. It's totally cool. Just remember that you don't have to memorize anything. Just know, try to understand what you have to do. Try to understand where you want to go with it. And then search for that specific thing, either in the pandas documentation, which is really cool. So either that or just Google it. And it'll take a while, it'll take some practice. But eventually, as you see, I'm not really referring to anything. Okay, the last plot is a dist plot, a distribution plot. So if I again do shift tab on this, it's a univariate distribution of observations, which basically means it considers one variable and then it'll plot the observations throughout uh, the whole distribution. So age and a percentage I would guess it's just not a percentage, but a distribution of it. Okay. Um, I will, yeah, it's a histogram. It's just a histogram, but the distribution is the curve. It's just a histogram with a added distribution curve. I mean, it makes it easier to understand the data if you have a larger data set than this, and maybe more complexity for the data. Okay, guys, I will stop with pandas here. If you, I mean, I will put up a link and I will continue with the NumPy part of it. It will take a little more time, I guess, but maybe a max of around 20 minutes more. But Zoom has a limit, so I can't really continue with this. Okay, before I stop this bit, any questions so far? Just put it on the chat and try to send the chat to everyone so people can see it. Any questions about anything I've talked about so far? Just feel free to ask. Mm, okay, cool. If you guys don't have any questions so far, that's cool. If you, I will send you the link to this data set and even the notebook I was using so far. Um, have a look at it, try to play around with it, Google stuff about Titanic, and there are a few notebooks as a bonus. There's this one notebook which I personally found was really cool. I will send you the link to it as well. Um, this guy has done an amazing job at it. Just have a look at what he's done, try to understand. If, as I was saying, there's a lot of types of plots. You don't need to understand everything right now, but just have a look, see the kind of stuff people do. Again, you would generally not do so much for a small data set, but this is a compilation of things which people do. So have a look at this. Yeah, and thank you. I hope you learned something about pandas. This is by no means an extensive